All right. I think we did it. I think we're live. Hopefully, we don't have any audio or video issues today, but I appreciate everyone's patience as we try to navigate YouTube. I saw in the chat that people were saying that we didn't unit test the
Yeah,
code, but you know what? I think that's on YouTube. I want to reach out to them
yeah.
and
We,
see.
we don't work for them, guys. It's not our fault.
Yeah.
Maybe they should watch this video.
Yeah, so I don't know. Maybe YouTube didn't run the appropriate unit tests, but in any case, let us know in the chat. I got chat open here. If anything, is amiss as far as the audio or the visual, we'll try to deal with it as we go. But yeah, thanks everyone for joining. As you see in the title of this stream, we're going to be talking about automated testing in Unity. Purposefully named this automated testing and not unit testing. We'll talk about that soon. But before we get into that, want to do a little bit of housekeeping as always, and that includes saying, don't forget to hit that like button because, it lets YouTube know that you're enjoying the content. And after this is posted, if we missed anything in the chat, any questions that come through, please drop those off as comments on the VOD that will go up after this video. So just a way that we gauge, what you guys are interested in and what you guys like to see. And then one last thing before we jump into this is something that I've been wanting to start doing is thanking my patrons here on these live streams. You guys, you do a lot to support the channel and everything that we're doing here. So I would be remiss not to mention a shout out to y'all. Thank you to my patrons every week, each and every one of you, but especially my Tier 3 patrons, and if you've ever been to my Patreon page, you'll know what that means. I'm going to shout them out now, and I'm definitely going to butcher a lot of these names, so please forgive me, Tier 3 guys. Thank you, Umut Sirin, Anton, Mighty Possum, Amar Duranovic, Dustin, Glasswell Entertainment, Nav from Academy of Games, Usif Ali Castle, Yakub Al-Safari, Iron Alex, R-Star, Trond, Dark Rush Photography, and Thomas. Man, you guys are awesome. Thank you so much for the support there. Okay, I think we did it. We got everything out of the way. Thank you all for being here. Jason, what are we talking about today? As you take a sip of your coffee. Great timing. My bad.
Yeah. Let me wake up a little bit first.
Well, there's a lot to talk about in this subject. So yeah, I'm sure we're gonna have to break it down as we go.
Yeah, I think we called it testing because that's sort of where we want to get to. It's more the answer rather than the question. I think what inspired me, at least in terms of attacking this subject, is I've had about 4 or 5 different people ask some variant of how much pre-planning do you do? How much code is written before the first line of code, so to speak? How much architecture or planning do you do? And the answer is very little, but it's more complicated than that. And so I thought we could work our way through that sort of concept and explain more of what that really means.
Yeah. I mean, on that same note, there's all sorts of tools as well that, I'm sure plenty of people know about, like or UML diagrams and whiteboarding, whatever that really means, and business requirements documents that may or may not. Yeah, user stories, things that may or may not include some details about the implementation. But yeah, it's interesting because, in game development, I think the general approach, being that a lot of game developers who download Unity and get into it are not traditionally not from traditional software development backgrounds, a lot of the times you kind of I think a lot of folks treat it like they do art. You have a blank canvas and then you just start doodling and sketching, and if you're doing like a figure or a character, you might like sketch out the anatomy and then fill in the pieces from there. And I think software development can be like that, but that could also be kind of a negative approach, or approach that could lead you down some bad paths, I guess is like a high level way to say it.
Yeah, I like the metaphor because it's the same thing for music. So I use the phrase classically trained programmer. It's basically, if you come from that scenario of doing it the business way with all of the business stuff, you would have been taught that with an eye for working in an enterprise situation, which means they will teach you things that companies want to see you have, like knowledge of testing and knowledge of, again, requirements documents and that kind of stuff. But a lot of people might look at that and it feels snobbish, right? It feels like it's a bit elitist, like it's coming from a very impractical pen and paper approach, which is kind of almost at odds with game development, which is a lot more about creativity and sort of freewheeling. And I think that's a myth. I think that's one of those things where it's like, old school art versus new school. I don't think it works like that. I think realistically, I keep trying to tell people that, from my perspective at least, it's tools. They're all tools. They're all options. They're available to you. You can either, the whole point of literally everything we talk about, whether it's testing or design patterns or clean code or whatever, it's designed to add value to your project or to what you're doing. And if it doesn't add value, then don't do it. Don't use it. Ignore us. If it does add value, use it. And we think it adds value. It adds value to the years of experience we've had. And so you basically pick and choose what works for you. And some of this stuff, I think, is because it's not traditionally done in Unity. That's why we're covering it. We're not saying this is the best or right way in every scenario. We're saying here's a bunch of tools that you may not know exist because the kind of approach you would have taken to learn game development wouldn't put you in this direction. So here's a bunch of stuff from a different discipline that's tangential, that has stuff in it that could make your life easier. And you can choose to use it if you want to use it. That's basically all we're saying.
Yeah. So there's the disclaimer. A disclaimer I probably should have made at the beginning of plenty of my videos, especially like my Zenject series, where, if you guys are not familiar with Zenject, it's a dependency injection framework for Unity.
It's Extendject now, isn't it?
It's Extendject now. I should say that. Yeah. You want to download Extendject. That's the one that Steve Vermillion, the creator, is actively, working on. But, the idea is that something like a dependency injection framework or any tool, another common example would be like some sort of multiplayer or networking framework that you might use. Those are all just tools to have in your tool belt, and it's good to know them. But there's no one right answer for all situations. Now, you mentioned something, Jason, that I think is important to talk about, and that's adding value, because I think that is an obvious thing to hear and say, but something that, it made me think about when I was a younger developer, that I didn't really know what was valuable. And my perception of what was valuable was kind of askew. Using dependency injection frameworks as an example, there'd be projects where I would be like, okay, I'm going to create this app, and but first things first, I need to figure out how I'm going to handle my dependency injections, which would lead me down this rabbit hole, hours, maybe days of trying to get just the right framework and get it set up in my project. And here I am thinking I'm adding value because I'm adding dependency injection up front, so that when I get into the real development, quote unquote real development, then I'll be in a good place. But turns out that isn't always a valuable thing to do. What do you think about that?
Yeah, I think it's almost like a necessary step on the journey that every programmer does at some stage, which is it's weird. I mean, it sounds like a silly thing to say, but it's like when people say about children and creativity. If you ever worked with an art teacher of any kind, or even a music teacher will often say something similar. They'll say that children naturally pick this stuff up because they just sort of do what comes naturally and intuit it and just work with it. But adults, as a general rule, try to apply reason and logic, and what happens is they end up kind of overcomplicating things and losing the creative part of it. Yeah. And you can kind of see this almost like a journey with a lot of software developers, where they will start out by saying, here's the tools for logic gates and basic functionality for if statements and while loops and whatever, and they'll start creating crazy stuff, just throwing code in, and they'll write literally the lines of code required to solve the problem because they don't know any better. They're not thinking about the scalability of the software. Right. And then you hit a certain point in your career and you're aware software has to scale, and you've seen systems that are big, and you started reading up on what patterns and practices people use. And so you start sort of trying to preempt that, and you start writing systems that are bigger and more complicated. And it gets to the point that the code you're writing isn't solving any problem. And all of a sudden you're writing more architecture than you are code. And it starts to get into this weird territory where you've lost the actual point, which is writing code that adds some kind of value. This isn't to say architecture doesn't add value, but the way you add value through architecture is not through this pre-architecting a giant super system, which we'll get in more detail to.
Yeah. And, it's funny because if you go back to the example of like doodling and sketching, I know that I'm going to want to draw a character in some position. So the artist, the trained artist will start to sketch out the form first, and those will be nice sweeping lines. And then they might start adding perspective, and that sort of gets built in. And eventually, yeah, you end up with this complex drawing of a character who might have clothing and accessories and a facial gesture that conveys some sort of emotion, but you have to get there piece by piece. And the value that an artist adds from the very first step of doodling or sketching out the form is the value I'm trying to get is, okay, what is the composition of the piece overall? And then they start getting into the details. Okay, what's the perspective going to be? And that adds value. And I think that is what we're talking about when you're creating software, or in our case, you're developing a game that requires code. You need to be able to figure out what is the value that you're going to add. And for me in the beginning, and for many developers, you start thinking, well, the value I'm going to add is I'm building this, from like the dependency injection framework. I'm going to put down this at the base level so that I have a nice, strong foundation. But that's not really providing me value right now. That's providing supposed value later on. Realistically, what is the value? Well, maybe in the case of the dependency injection framework, I know that I want to have a spawner that spawns enemies. And my thought process is, well, all my enemies have dependencies. They need to know what the player is, and they might need to have access to some sort of, audio manager or something. Realistically, the value is I need to spawn things into my scene. So that is the code I should be working on. And then when things get complicated and I start to realize, oh yeah, every time I spawn an enemy, I have to make sure I load in all these dependencies on them. Well, at that point, the value is, yeah, I can chase down a dependency injection framework and see if that's something that, plays nice with my project. So yeah, I think value is a really important thing to understand and to be aware that maybe you don't have it right the first time,
There's no maybe about it. You certainly won't have it right the first time. I guess the metaphor I like to use for this, to kind of liken it to software development, is say you're planning for a journey. You're going to go on a trip around the world or something. You'll write down your plans in the form of, first of all, you write down the entities involved, the elements, the larger pieces. This country, this country, this country. Then you would plan, how will I get from A to B to C, and what hotels am I going to visit? And then you plan the details. You plan the bus, a taxi, whatever else. And that gives you the shape of the experience you're going to travel through. You don't plan, like, how many steps from you get off the bus, how many steps forward do you take, what degree rotation do you take to go to the next direction? And it seems weird that people associate what you either have to go all or nothing. You either need to, people think you need to plan this giant super system, or you just do it creatively and you don't do it planning at all. And it's such a weird, false dichotomy. You don't have to pick one or the other. Realistically, you give yourself enough information to know that you're walking in the right direction, and then you just start walking in that direction. You figure out what the plan is and you start moving that way. I find if you try to over-engineer, you're making so many hidden assumptions that will end up biting you in the ass, because you'll start abstracting out interfaces that don't exist yet for systems that aren't decoupled yet. And so you don't actually know if that's the right contract. But the inverse is true, is if you start writing code and plan nothing, you will end up in this weird scenario where you'll be halfway through a system and go, oh, hang on, it turns out I actually need this should be a class instead of an array of elements or something. And you'll have to suddenly like rewind back and figure out how to unpack a lot of decisions. And so if you know enough to get you going, you're able to architect safely. And that's where a lot of strategies around software development are designed around the safety to apply change. So agile development, test-driven development, all of this stuff serves one main purpose more than anything else: to be aware of the fact that software changes and to allow you to sort of safely grow and experiment without ruining stuff you've done in the past. So if it's not adding that value for you, don't do it. But the fact is, that's what it's for. It's to allow you to scale and make changes with safety and the knowledge that your code will sustain those changes as you go.
Right. Yeah. And so what does that look like practically? Well, again, once you define what your value is, what is the value you're trying to get right now? You need to take an iterative approach. So, going back to the spawning example, your real goal might be you want to create, what's a good example of a game that has like random spawning? Maybe you have a game that's like one of those tower defense games, and you're like, okay, I want to spawn enemies, right? So at the highest level, the biggest sweeping, description of what you're trying to do is I'm trying to make a tower defense game that spawns enemies that increase in difficulty as time progresses. Okay, fine. But you don't want to start there. You want to start at the lowest common, or the smallest building block is, which is just spawning something. It's just spawning an enemy. Well, the next thing you might think is, well, shoot, the enemy has to move throughout the little level here. So that might be the next thing you tackle. Okay, well, he follows a path. All right, well, now I want to associate some sort of difficulty to the enemy. Well, you have to figure out what that is, and you take that iterative step, so on and so forth. Eventually, you get to that point where now you have your tower defense game, but it's that iterative process that is I think the most important, because just like Jason was saying, you want to be able to develop your software safely in a way that you don't have to come back and redo things, and also in a way that you don't lock yourself. Which, you might have heard the term coupling. You don't want to couple your code to a point where you're locked in and you've got one class responsible for way too many things, like playing audio and changing the level and setting the score. And I think really what's important is, with planning, if you take an iterative approach, then you can plan each iteration, and that way you'll be able to write things that are more decoupled. If that makes sense.
And one thing that really kind of bothers me about the discussion that circles around testing, especially, is it feels like a lot of people treat testing in things like games as a sort of a zealot type thing. Is you either need to be, you're either one of those testing people or you're a normal developer. And it seems like it's a secondary thing. But the way I would prefer to look at it is it's more of like a safety check. And a good example of this would be, I think, okay, let's put a small example here. Let's say you had to run a piece of code and it's life or death. If this code works and does everything it's supposed to, you live. If it makes a single mistake, you die. It's life or death, this piece of code that has to run. And I offer you two choices. I will either give you 80% of the code pre-written. Sounds great. 80% of the code, start you off, and then whenever the code's done, you'll give it back to me and I will run through a series of things I want to do. And if it breaks once, you're done. Or I can hand you a test suite. And a test suite checks everything that I will want that system to be able to do. It'll run through 200 tests and it'll verify every system does whatever it's supposed to do. Now, the code doesn't exist yet, but the test suite will check and give you a nice green check mark whenever it's done. Now, which would you prefer? If I offered you both of those things, and then at some point we'll run one test to see if it works, and that's life or death. I don't know about you, but personally, I would like to have the pre-check, the knowledge that it works before I do the real thing. And I think this is one of those things that a lot of people aren't honest with themselves about. That's probably the right way. Now, the question of do we need it is a different question. But realistically, in a perfect world, that would be nice to have. The question of does it add value now? Is it too much work for my game? These are all valid concerns. But let's be real here. The idea of are tests valuable is kind of pretty much an obvious self-answer. Of course they're valuable, because if you could have the perfect suite of ultimate tests, you'd probably take them. A lot of the reasons why people don't want to do that is because of a concept called brittleness. And it basically means your tests are written in such a way that changing the code forces changes to tests. And you do that, you have a code base that for about 3 weeks changes almost every time you change a line of code. That'll drive you insane. You'll get fed up and you'll eventually dump the test suite, saying it's not adding value. And that is the real reason why a lot of people don't do tests, because they don't do it right, because they realistically write tests that are coupled to the code they're writing. And so if we take all of the sort of the high level philosophy and the back and forth about it and just say, if I could somehow have a test suite that would verify my code works, but it's not difficult to maintain and it's easy to update and change, would that sound like a valuable proposition for your code? And so that's where we should be. Not the question of is unit testing valuable or not, because it's a pain to manage and it's a lot of effort to write. Realistically, is it valuable? The question becomes, how can we lower the barrier between it being too much work and it being something I actually want to have in my code? Because I think if you're being honest with yourself, it is of course valuable.
Yeah, and that is always the argument against unit testing, because I find that when I talk to developers who are adamantly against unit testing, I think the conversation is always the same thing, or it seems to be. I get it. I get unit testing is important, but honestly, it just takes too long, and realistically, most of my code works anyway. So what difference does it make? And I think that's very limiting because in the end, I think so. The first part of the argument is it takes too long or it's too complicated, and I think that just comes with skill level. I think those developers that I speak to about unit testing who speak very informatively about it, they don't actually know how to do unit testing. They may know at a high level, but they've never actually practically done it because the first time they tried, they found that there were questions that they had and they didn't know what they were doing. And sure, it's like anything you do for the first time, you're going to fumble around. And plus, there's a lot of questions that do arise when you're writing unit tests about how do you write the code? Should you treat it like your actual code? Is it special in some way? Valid questions. But if you were just to take the time, and I'd recommend any developer take the time to add testing to your tool belt, really putting in the time to learn it. I mean, when I learned dependency injection and even learned about Zenject, I spent a considerable amount of time trying to understand the framework and the concepts behind it. And I think many developers are not afraid to do that. Another example that I used earlier was like multi networking libraries. Like you do need to understand networking in order to use those libraries, and many developers will spend the time understanding the concepts and then going through the documentation and learning it. So why not unit testing? If I think if many developers would just give it its due diligence and learn it, then they would find that it isn't really as time consuming as they think. In fact, it actually saves you time in the long run, which is another, argument that I always like to say, but it's very hard to get across that like writing tests literally will save you time in the future.
And this gets to one of the only arguments against test-driven development that I will consider a valid and good one, which is the question of a lot of the value of test-driven. I wouldn't say test-driven. I think unit tests in general. Let's be a little bit broader. The value of unit tests in general is basically it allows for code to change safely. And that's kind of what I was getting at, is that it allows you to refactor, clean your code, move modules around, rewrite new implementations, and still be comfortable that the system works. And in a lot of cases for game development, you may not be reusing the same engine. So you will write a game, you will write the code, and DLC is traditionally like an add-on. You're attaching stuff to it. You're not rewriting the existing code base. And so one of the major concerns on that front is enterprise-level software is often the underpinning of a company. It's something that is added to a company, and it's going to live there for 10 years. Yeah. And a lot of people who don't work in enterprise don't realize this, but when a company puts in a piece of software, there's usually so much red tape because it goes through, you have to be on a particular image on the machine, different people have access rights to it. An entire business backend could be dependent on it, like thousands and thousands of dollars could go through this system. And so if you're a software developer who made this tool and you go to the client and said, oh, we've got a new update, just click update there and patch the software, they're going to say, why? It works perfectly fine for us. We're not going to take the risk that there's a new bug or a new issue that isn't there already to patch our system. So realistically, the point of a lot of test-driven stuff in enterprise is to have a sense of certainty for things like patches and upgrades and changes, because that could literally be the end of a company. You can put in something that breaks the system in such a way that auditing is wrong, and then all of a sudden they're in trouble with the IRS, and you can take down a company with the wrong line of code. And it wouldn't have to be like a big deal. It doesn't have to be something as big as like messing up accounts. It can be something as simple as not logging names with stuff that happens. It really depends on what the rules are for the system you're building. And so a very valid concern is, why do I have to write as if I'm doing the Fort Knox of software? And I'm saying you don't have to. You don't have to lean into the full, giant test suite and multiple redundancy. But just saying that you're not making a super enterprise piece of software is a pretty bad argument to sort of hand wave away the entirety of every piece of valid information that's useful in the kind of business sphere of how to do software development. And from my experience, the line tends to be around systemic stuff. So I personally don't like to test stuff where it's more driven around creativity. So I don't test my character controllers as much. Right. I wouldn't do that kind of stuff, because writing tests to say if press left position +1 on the x-axis is kind of a little bit tedious, and it doesn't really tell you anything. And stuff like, if you're adding 1, you're basically adding speed, and then you're kind of saying how fast I want my character to go, and you'll start playing with stuff like jump curves and all sorts of stuff for game feel that kind of defeat the point of those kinds of tests.
Right.
What you should be testing is data integrity, and that the system validates to its own rules. So you can take out stuff like testing like death boxes in your game, or testing gun reloads, or timers for reloading. All of this stuff is things that you can test work, and then you can tweak the values in your system. But you can write it without being part of the game. Like the example I used before being a vending machine, there's a lot of artistry in that in terms of animations and stuff swiping up, and do you stagger the UI, and are they spinning 3D models versus like sprite image? Like you can do a ton of creative stuff, but at the end of the day, display a list of items, validate that you can buy it. Do you have enough money in your wallet? Is this person the right class or level or whatever to purchase it? All of these are validatable statements that have nothing to do with any decision about what's in the store, name of the guy who owns it, what the models look like. All of these are artistic decisions. And so there's no brittleness to the tests there, because you're testing if the rules of the system function irrespective of what you draw. And so the question becomes, do you write unit tests for everything? No, but specifically for this kind of a system, there is so much of your logic that boils down to switching items in an inventory, or picking a particular thing, or incrementing the experience of the character, or all of these kinds of things, like generating random stuff and spawners and all these kinds of things we talked about, where you can verify they work and then slap stuff on either end of it and put it into your game. So there is value in it. You just have to know when and where to apply it.
Yeah, and I think that is such a paradigm shift that if a developer can get there to that idea, then now you've come to a place where you're developing an inventory, for instance, like it was one example, or a vending machine, and never actually having to run Unity. And this is something that Jason and I were talking about the other day. An example that he came up with, and I came up independently, but slightly different. His example was like an engine in a car, but I like mine a little bit more. When you think of like the developers at SpaceX, right? There are all these things that the software has to do as a rocket shoots up into space to make sure that it's aligned correctly, that given certain wind conditions and pressure in the atmosphere, self-correcting, all sorts of things like that. Even things about distributing the fuel in the appropriate amount of time so that they don't overdo it or underdo it. All this being said, they're writing all that code without shooting a rocket every time they press play in their debugger. You know what I mean? Like they don't need to shoot the rocket. And you can think of Unity as the rocket. If you have an inventory and you're writing that logic, you shouldn't have to hit play in your Unity editor, get your character to run over an item in the game, open up the inventory, and look at it to make sure that your inventory is getting filled and the items are stacking appropriately. That should be run in memory in a unit test. And once you get to that point where you can really break apart your code, well, now your inventory is no longer a mono behavior. You may have like a wrapper mono behavior that holds an instance of an inventory and knows how to interact with Unity's ecosystem.
Humble object
pattern. Yeah, I've got a video on that. Definitely check that out. But yeah, you might have a humble object that's like talking to the inventory, and it knows that it has a trigger, and whenever the player walks over an item, then the trigger knows to send the item to the inventory. But realistically, all the inventory is in your code is a list of items, and there may be some intelligence on how it stacks those items, and there may be intelligence in if someone were to quote unquote use or call .use on an item in the inventory, well, what happens? Does it get consumed? Is there a cooldown? And those are the things that you should be testing in your code. If you come from the business world, like Jason and I, you call those the business rules of your application. But in game development, I tend to call them your game mechanics, your underlying game mechanics. An inventory in Minecraft acts very differently from an inventory in, say, Skyrim or World of Warcraft. You get the idea. Every game has.
Stacking's a great example. Like a lot of those games have a stacking mechanic where you put items in inventory, you can auto sort it, you can stack similar items. There's a max stack count. If there's more than a max stack count, it moves to a new stack. All of this can be easily tested with like an array object of some kind with a bunch of rules that say add 10 apricots, add 50 more apricots. Oh, you've hit past the stack size, make a new stack. Like, you can do whatever you like and just test it, and you don't have to like literally drag items in the inspector. Like, obviously that's part of the code and there's stuff that can go wrong there. But if you've got a fully tested inventory system that's just a bunch of flags being turned on and off and all of the int values, and you verifying that it works, when you attach a UI to it, and when you put it in Unity, and when you attach the drag handler on one side and the sprite renderer on the other, and you start dragging sprites in, if something goes wrong, you know it's only going to be something to do with sprites or something to do with drag handling, because all of that stuff to deal with the stack counts and all that stuff is tested. You know that works because you've got a whole load of tests written to verify that that works. And if you decide to change that later and you want to say, you know what, we're not going to use the Minecraft style inventory anymore, we're actually going to go for more of a Resident Evil build your own inventory thing, you can write a different system for that, and you can then drop it in and move some stuff around. And the amount of kind of wrenching out existing systems to put new stuff in is a lot smaller, because you haven't sort of, if your UI or your interface system for your inventory is built around the hierarchy of game objects and how stuff moves, changing that to a different system is fundamentally going to be gutting out and putting in a new one. If your system works as code and you swap out code for code, I'm not saying it's an instant one-click swap, but like there's a lot less work because you have a system that you swap in a new system and you attach things either end.
Yeah, yeah, and Tylo in the chat there mentioned about like testing drag code, which is tied to Unity Engine. Exactly, I wouldn't test drag code. Drag code is something that's a part of
code. You're right. That's That's a general rule.
I assume that dragging logic is something that Unity has tested. And same with like trigger enter and things like that. Things that you'd imagine would trigger an item going into your inventory. Like you hit some object in the world, you get a trigger enter, you pick it up and destroy the game object. I'm not going to test that logic. What I'm going to test is that if something were to call .add to my inventory, then the inventory is going to treat that appropriately, because there could be many ways that things get added to the inventory. You know, maybe your character takes a quest and that adds an item to your inventory, a quest item, or, you know, in the inverse, maybe there's some part of the game where, you know, it's towards the end, the climax of the game, and there's some cinematic, and now everything from your inventory has been removed, you know, for whatever dramatic effect. Well, you can do that as well. And even when you start. So this is another concept that Jason and I spoke about a couple weeks ago, is when you can write your code in this way, and that it's very decoupled and it's very, you know, for lack of a better word, hot swappable, you can really have some more sophisticated and interesting things happen. For instance, maybe you can swap out your inventory, the one that's active with all your stuff, with an empty inventory, and then swap it back, like in that scenario that I just described, where like, you know, you get stranded on a desert island, but then once you get back to the mainland, okay, now we've saved the player's actual inventory somewhere in memory. Let's swap it back so he has all his items. It's just you can really start to get more complicated and sophisticated game mechanics that you may never have even realized. What's it called? Emergent design.
And the thing is, there's a lot of other stuff too that very similar to the vein of what Charles is saying, that unfortunately we can't explain from a starting point. So unfortunately, when you're doing tutorials or explanations like this, you have to start at the beginning and work your way through. But a lot of the value of this stuff comes from middle onwards of the length of a project. So a good example of this, and if you go to, say, unity3d.college and look at Jason Wyman's stuff, and he'll talk a lot about working on MMOs, that's his area. And what he'll say is he's particularly proficient at tooling. That's the thing that he's done the most, is that building tools to allow designers to work outside of the app. So a good example of this, if you've got a game that's got a lot of maps or a lot of items or a lot of whatever, any sufficiently large game is not creating maps by opening up Unity and dragging stuff around. It's just not realistic, especially 2D type games. Usually if it's grid-based, you build something that lets you do that easily. And you can build tooling in Unity. Unity is great for extending that kind of stuff. But sometimes you want to use something else. So a good example of this is if you've got an item database. So you've got a list of all the items in your game. They've got different strengths and weaknesses, and you've got different creature types with counteracting, elemental damage or whatever. You can store it in a database somewhere and you can start playing with it. But realistically, here's your chasm. You can either work with it in Unity, which requires proficiency in Unity to work in it, or you can work in the database and just change the numbers, and then you need to have proficiency in the database. Or you build a small form app or a web app. It's like less than 1,000 lines of code, You could build a nice window that connects to the database, gives you some nice grids, gives you automatic buttons for create default fire weapon, create default lightning, whatever. And you can build tools that will help you populate your databases, manage stuff, see what's wrong, compare different stats, and you can do whatever you need to do as a tool. And here's the interesting thing. If you write test-driven style code as a concept that's platform independent, like adding to the item database, removing from the item database, creating new items, all these kinds of stuff, you can actually use that code in your tooling. So when you go to make tools later that are designed to draw the map, say you use something which paints a sprite thing, something that you don't really get into in online tutorials like this, because it's kind of like, it's quite far down the chain of game development, is a lot of people will actually, maps sometimes boil down to either a bitmap or it'll be a text file of just the actual grid squares in characters or integers. So your actual map is in the form of CCC, I, CCI, J, I, and each one represents a certain layer of collision or certain tiles or whatever else. And that means that you basically load that in, apply different sprites to it and render it. And theoretically, you don't need Unity to build that sprite map. You could build that by just painting some red and blue blocks in even a separate Unity app or whatever else, as long as the spat out output is something that can be read in by your game. And so when your game gets officially large and you want to have lots of people making lots of maps and lots of whatever, sometimes you want to have tooling that will allow you to do that without all of the other mess of loading the engine and going through all the stuff. And you don't have to think about a lot of the complexity of that. And so, long story short, code that's written platform independent literally can work for all of that stuff. And that's just a microcosm. The same thing applies for high scores and dealing with the entire score system of your game, for statistics and gathering analytics for your game. Networking, you can, most people don't realize this, you can build a headless server for Unity multiplayer that has nothing to do with Unity. It is literally just like a UDP port thing, and it just receives messages, and it just happens to come from Unity. So you can build a multiplayer game that's cross-platform, and one's built in Java, and one's built as a Unity app, and one's built as a web canvas. And the multiplayer aspect is just a central hub that has connections back and forth. It's a sort of very naive implementation of software development to see your system as being a Unity app or a web app or whatever. These are usually considered endpoints or front ends on top of some system. And that system isn't always tangible. It could actually just be the interconnection of protocols and stuff that goes on behind the scenes. And so wherever possible, the amount of decisions you can take out of that, the better. If you can write your code without deciding it is definitely SQL, it is definitely in Unity, it's definitely whatever, and you just say, this takes some items, applies the rules in our system, spits them out and draws them, and then people can make decisions and pick stuff, and we will then change the items, we will update the items, and then we will store those changes. If that's the heart of your application, these can change, but the core is the bit that goes with you in future systems. And that's what's scalable. Now, again, scalability is the thing here. If you don't need scalability, maybe you don't need all of this stuff. But there are elements of it that will make your life easier, and you will start to see them more and more in larger games and projects. And so it's worth knowing them just to give yourself that leg up.
Yeah. Well, and you say that, you may not need scalability, but I don't think scalability is the only value you get out of, architecting or working on a project like this, making sure you code a project like this. I think you really do, even at the small scale. And I can speak from my experience working on my little sheep game. I'm not anywhere near the middle of the project. I've very little functionality in it. I can move around. I've got a grid system and all that, whatever. But I'm already seeing emerging more complex behaviors that I could now achieve because of the way I wrote the code. And I wrote the code in a way that is, what you would consider scalable. It's very decoupled. I have each bit of logic or system, if you will, in its own namespace, its own assembly. And I just wrote it like that because as I iterated on it, I decided to just focus on one piece at a time, one game mechanic at a time. And there were times where, for instance, and we may get a chance to look at this project later on in the stream, there were times where I was looking at the camera follow logic and trying to understand, how am I going to implement that? And at first I thought, it's going to have to be a part of the movement system because the movement's going to have to tell the camera when to reposition. Well, turns out I was able to write it in a way that it was just completely separate. And now those movement and camera follow logic work in, synergetically, but they don't know anything about one another. And now I can see that there's many other ways where I can take that top-down following mechanic and apply it to other things. For instance, maybe I don't want to follow the player around. Maybe I want to follow some, in a cutscene, I want to follow around an enemy as they walk around a dungeon. Everything's going to be the same code, the same logic. I'm just going to target a different entity. And I was able to accomplish that because I didn't couple it into my player movement logic.
Yeah, an example we used way back when was we talked about the idea of something holding water. You might have the concept of a bucket in your game and it like fills with water. And based on the level of water in it, maybe it's heavier, or maybe, if it's near stuff with fire, it doesn't get as hot, or whatever other mechanic you have in your game.
Right.
And you conceptualize it as a bucket. That's what's in your head, a cup or a bucket or something. But you could later on decide that there's rain in your game. And you could say, oh, hang on a second. I happen to have rain. I happen to have this water containing system. What if I said water fills things that could contain water? All of a sudden, you've got buckets to fill with water. And then you think, hang on a second. What if I add clothes have a certain amount of dampness? And all of a sudden, clothes can contain water. And it's just like an extra interface you attach to it. You sort of acquire water to it. You max it.
You could have plants that die if they don't have enough water.
Yeah. And so suddenly your creativity is expanded by the fact that you didn't just solve the problem you were solving. You solved it in a way that lets you, again, grow and change your code in a comfortable way. So a lot of this stuff, there's just a lot of value in sort of the later stages of this stuff that's very hard to describe.
Yeah, but no, that's a really cool example actually, because I'm thinking of all sorts of concepts there. Like, if you were to program a bucket, in Unity, and you took the in Unity approach, like you're just building to the rocket, you might first make a mono behavior, name the mono behavior bucket, have it maybe have a method or it checks on some sort of trigger. If it comes in contact with another game object that has the tag water, in that way you're really coupled to Unity and there's really no flexibility there. But if you pull it out and you program it separately as its own class library or its own other application that's sort of a system, then you could do all sorts of things with that. For example, a plant needs water, your clothes could get damp and that could make the player exhaust more stamina. Or maybe you have like electronics in your game, and if electronic has too much water in it, it breaks. Exactly. Like there's so many, and that's what I was trying to talk about earlier, that emergent design, that complexity and sophistication that comes out of something so simple just by decoupling it and treating it like its own thing. Now you've got like the possibility space is just unlimited. It's crazy.
Yeah, and that sounds like a abstract or esoteric example, but here's a more down to earth one that you're already doing probably is if you've got any kind of characters in your game, you probably have health, and the idea of health is just a number that ticks down. And you could think of it as a health value, and your players got health, and then you've got NPCs that have health. And at the end of the day, it's only a few lines of code. You can just write it in for every character and whatever. But rather than health, what if you conceptualize it as like the idea of a meter, or as sort of a damage value? And so when you start to abstract this stuff out, you end up with realizing that what you're talking about is stuff that can be damaged and something that can be repaired or healed. And so all of a sudden, you can have systems like crates or boxes that can be destroyed, and they can receive the same events a player would to receive damage, and it'll apply to everything, because you're not programming a health system anymore. You're programming a system that has a meter of value that goes up and down and can be clamped and has mins and maxes and all this kind of stuff, and you can use it to represent A, B, C, and D or whatever. We're getting vaguer here, I think, so I kind of want to pivot a little bit back. But I will say one last thing on this angle. There's probably one other area to testing that I really want to bring up that I think will add a value people don't think about. So when I do a lot of tutoring, and I find that there's usually two camps of people for this kind of discussion. There's people who are really good at just getting things done, which is a skill I don't have, which is just sort of like powering through.
Yeah.
And we talked before about how it's like the creativity that kids have is that instinct that I want to do a thing. What is the minimum quickest way to do that? Get that thing done, and they produce it. And to those people, we have to convince them that testing has value. And basically, until they try it for themselves, and that they wouldn't do as much as we would, because to them that slows them down. But I still think it would add value. But there's the other half of that we haven't been talking to yet, which is there are people who are like myself, whose instinct is the exact opposite.
Mm-hmm.
They want to be able to write down this like 50-page map of
that's
every
me.
single.
That's me too.
Yeah, like it's a lot of people who fall into the trap of getting into architecture sort of really enjoy the sort of logical consistency and systemicness of the whole thing, and they want to write it out. And then what you end up doing is you end up freaking yourself out and psyching yourself out because you start thinking, okay, I'm basically, it's the matrix here. I've got like a million pieces and I have to move them in the right thing and connect them all and whatever. And the reason you're having this problem is that you're trying to solve problems that don't exist. So you're making up the problems and then you're trying to make up the solutions to the made up problems that don't exist yet. And this is going to drive you insane. And the way people usually approach this is they find out there's these things called design patterns. And that's really cool. I could use design patterns. If I just know all the design patterns, I'll know the answer to every possible problem that ever comes up. That's the easiest solution. And then you learn design patterns and you realize that's not working. Because as you start applying all of these to your project, you start making a mess and stuff. It's actually worse than it was before. So the problem you end up having is that you're trying to learn all of the possible solutions to all possible problems. But what testing does, and especially test-driven development, is you actually don't do that at all. So for people whose minds go crazy like this, if you start with test-driven development, you start with, I have a health bar. Health bar starts at 0. Check. Health bar, when I add health to it, health goes up. Check. When health is greater than max health clamps to max health. Check. And all of a sudden, all of this stress of building the most modular, super mega system that can have like all that water stuff we talked about, all of this crazy idea of, but what if I want to have boots that can have water? And then, what if it lands on something that's hot and the water evaporates faster? Do I have to factor that into my design architect? No, you don't design for problems that don't exist yet.
Yeah.
But what we're saying is the design we discussed allows you to start with a thing that is water containable. And as the requirements change, you can attach new things to it. And you'll actually find it feels like it grows naturally to fill the space it's in, as opposed to starting outside in where you try to solve every possible conceivable problem. And so if you're in that mindset where you tend to over-engineer and freak yourself out, get into test-driven development and kind of learn how to step and iterate your design. And this is where we say this all of the time. Design patterns grow out of a system. They're not something you apply to a system. And it's something that you'll start to see more, and it'll really click with you if you start doing test-driven approaches, because you'll start to realize that a design pattern is what you name the thing you did once you got to a good architecture. It is not the thing that you take from somewhere else and stick into your code.
We had a good question here. A lot of good conversations happening in the chat. Don't want to think that we're not reading it. What if I add multiplayer? Hitoshi Kano says, and the answer to that is easy. Don't.
Don't do it. Well, okay. The less maybe answer to that question is multiplayer, as a general rule, is synchronicity. Right? If you take everything else, if you strip everything else away from multiplayer, what you're talking about is making sure two things are in sync. Mm-hmm. Now, depending on the architecture and the kind of game you're doing, whether it's server authoritative or not, at the end, it could be the server doing all the work, or it could be the clients doing the work. Now, in real multiplayer terms, you want the server doing the work to avoid any kind of messing. But without getting into the nitty-gritty of that, what I will say is you're talking about taking information from other systems, consolidating state, and then updating the state. So if you've got a system, which is a health system, and you've got a system that is the current, say you're playing on some map, and then the map is like deforming and changing relative to the players, like shooting an earth gun at the ground, all sorts of crazy stuff. You could think of it as, I've got a multiplayer problem, or you could say, I have a system which makes the ground change. I've got code or events in my game, like players shoot gun at ground, that change the state of that. And I've got other events, which are someone else on a different server did it, and update my system to support those events. And you realize multiplayer is just taking events from somewhere else, turning them into the commands and applying them to your system. So if your system is ground that can change, whether that's being driven by a multiplayer external system or whether that's being driven by a single player experience, it's kind of irrelevant. It's actually not part of the system at all. Multiplayer is a thing on top of existing systems. And so like a good example of this, if you've actually used, if you've written your own networking in Unity, just like even the basic stuff, if you've used either Photon or just written a very basic server and connected to it yourself using UDP or whatever, it basically boils down to you take out the vector tree for position, you take out the rotational value for the quaternion, which is again vector 3 Euler angles, and you take out maybe the direction they're facing. And you take those values, you would turn them into bytes, and you'd send them across some wire. And if you think about it, that's what we're already doing. Unity transforms don't natively have multiplayer support, but they are a set of numbers. And if you can take those numbers out, send them to somebody else, they can take those numbers, reapply them to a transform, you've got multiplayer. And that's actually how those systems work. So if you're using Photon 2, for example, they've got this adapter, an I don't know, eye synchronization view or something. You implement that, all it is you adding and sending bytes. And so the point I'm getting at here is that's technically doing what we're saying. There is a system called a transform, and a transform does movement to transform stuff. It is not a multiplayer transform, it is a transform. And how do you get it to synchronize? You write some additional adapter, which will take events from somewhere and modify the state of a transform. And your systems can be no different. You can have stores and players and enemies and maps and all these cool stuff with massively complex systems. And you just basically ping each other and take states and update values. And not only is that not difficult to do, it is easier to do than trying to bake in some enterprise support for multiplayer in the middle of some system where it may not need to do it, you know?
Yeah. It's a, that is a common thing in game development, multiplayer, and it's such a sophisticated sounding, problem. But just like every other issue we've brought up, or any other system we've brought up, it really can be simplified when you just extract, like, what is it trying to do? And like you said, it's just trying to synchronize data values. So as long as you can, solve that problem and solve it separately, then it really becomes a simple thing to solve that has a very simple solution. Well, networking is never simple, but you know what I'm trying to say.
Yeah, and I just want to avoid any straw man that might be in the chat looking at you, Justin. I am not saying you can just slap multiplayer on at the end, but what I'm saying is a system, by its design, has nothing to do with whether it's single player or multiplayer. And you can design your game such that it's aware it's multiplayer and put support in for that in the architecture of the game itself. But the idea of a health bar doesn't have to be a multiplayer health bar. You can have a multiplayer character who uses a health system. That health system doesn't need to know about the concept of multiplayer. So I'm not saying that you can not do multiplayer at all, but I'm saying the things that multiplayer touches are the things that interact with the concept of synchronicity. They are not the individual core elements of your game. And if you've ever done anything massively complicated with collision or AI, you'll see this. If you're doing an AI system, it could be anything as like an RTS where you're moving troops across mountains, or it could be swarms of flying ships or whatever. Most systems boil down to a grid. At the end of the day, almost all of those systems, they're A-star, they're quad trees, they're octo trees. It doesn't matter what you pick, but they're probably at some point a grid. And if you turn to somebody and said, oh, look at all these 3D ships flying in formation. Oh, yeah, that's on a 2D grid. They'd be like, no, it isn't. It's like, yes, it is. It doesn't look like it. It doesn't feel like it. But logically, you can compress a lot of that complexity and solve it as a separate problem. And that's what you're doing. It's like a lookup table of your grid of stuff, and then your game. And your game uses a lookup table to really cut down on complexity. And in the same way with a complex system like a multiplayer shooter game, you've got a gun that shoots, you've got health that goes up or down, and then you have a synchronized player that listens to collision events and changes the health. But the bit that's multiplayer is just the player. It is not the entire system.
Yeah. So we've talked quite a bit about architecture. Why, you see something in the chat? You want to?
Yeah, no, I was just going to say one of the things that I meant to mention and I forgot earlier. So all of this idea where I'm saying So I guess the core message is one that I actually, funny enough, I read somebody else write this last week, and it kind of surprised me because it's exactly what I was saying. And it's like, I need to make sure everyone sees this. There's a guy, Amigos Code, and I'm going to paste it to Charles so he can paste it in the chat because I don't think I can. This guy did a video, and it's really good, and you should watch it. And he'll say a variant of what I'm saying, but he's not talking to the games audience. He's actually just talking to developers in general. And it may sound like it's the opposite of what we say. It's going to say, you shouldn't learn design patterns. And anybody who's into architecture would be like, what do you mean? These guys make tons of videos about design patterns. That's insane. Why would you say not learn design patterns? But if you watch the video, you'll see what I mean. He's saying, don't learn design patterns with an eye for slapping them onto your code. Instead, design in a way and work through your code where it will grow. And if you play it carefully and you just sort of grow your software and basically don't make a mess, don't run off on a tangent, but also don't over-engineer to start with, you will find design patterns happen. They occur in your code as a result of working. Now, knowing them is useful at enterprise level because you start being able to use them for shorthand. You could say, oh, I'm trying to make this change, so go and add it to the abstract factory or whatever. Like you can start shortcutting a lot of dialogue, but that's what they're really for. Learning them as a toolbox is kind of silly. And as a final note on this before we move on, is just, it's like, I've used the metaphor before, it's like learning what a plaster or band-aid does, and it's like learning what a splint does for, you know, an injured limb, and then having these toolbox, and then when someone comes in sick, you're just like, okay, I've got a splint, where do I put it? It's like they've got a bloody nose. Why are you holding that? It's got nothing to do with what we're talking about. It's because you've got this toolbox of things that you know solve problems, but you're not actually looking at the problem to try to figure out what to apply. You're just looking at your toolbox of problem solvers and hoping one of them will fit into the thing you're doing. And it's kind of silly in that perspective. You want to be looking at the problem, and hopefully, as you start to solve it. Now, it's good if you know these things, but like I said, you don't start with the options of solutions and then try to solve them, right? You try to grow the software and naturally solve the problems.
Yeah. Well, and that's kind of going back to the original example I had at the beginning of the stream, where I would, you know, spend so much time on dependency injection frameworks. I was trying to solve a problem that I didn't yet have, and I understood the design pattern behind that and the solid principles and everything that goes into that, but I just didn't need it. And I think that happens so often. Yeah. So, and again, to bring it back to what we were talking about at the beginning of the stream, trying to determine value, the value you're trying to create every time you develop iteratively, you should be trying to get as much value and as little amount of work as possible. And adding a dependency injection framework or trying to find some design pattern to solve some problem you don't have is definitely not going to provide you any value. And oftentimes, this is something that I've been trying to illustrate more recently, oftentimes you will solve a problem intuitively and look back and understand that, oh wow, this is actually something that's been defined as a design pattern. But you know, you don't need to look up the design pattern to get to that solution. Oftentimes you will solve it in a way that makes sense and come to find, oh, this is actually something that people know about. It's a design pattern. You know, they put a name on it. And I think in my humble object humble object pattern video, that's kind of the approach I took with Charles and Barles. You know, I was showing Barles how to fix his problem, and turns out, without even realizing it, it happened to be a design pattern. So I think that's a healthy way to look at and approach development in general. So just checking chat here, making sure we don't miss anyone.
So yeah, I think we've stalled the virtues of testing enough. Might be worth maybe jumping into something.
Yeah, let's do it.
How are we doing on time? Is it?
We have got, let me see here. We've been streaming for about an hour, so I'd say like about 30 minutes left. We can go 45 minutes if we get into something.
Yeah, so I guess rather than me trying to write a whole test suite and stuff like that, maybe we'll jump to your example project and we'll do a step-by-step test-driven thing next time.
Okay.
I had a feeling this was going to be a long conversation. I was estimating half an hour. I didn't realize we'd rant for an hour on this, but there's a lot to say on the topic.
So someone says, by the way, Vakral says, when will we get at least one stream with Barles? You know, I'm just gonna have to convince him. One day we'll see if we can get him out here.
Well, as you've seen, he's a bit shy. You know, he's not very confident on camera. So
he's incredibly shy. Maybe one day. I'm trying to reconcile the fact that I would actually have to act like another person, but it would be me. One day Barles will be on the stream. You know what, though? Maybe Barles has already been on the stream.
Well, there we go.
You just didn't know.
Meta for you. Yeah. You were sick one day, and he came in and took over.
All right. So the example we have here, I have a couple examples, kind of just nothing that I've really prepared on purpose. Just this is a personal project I've been working on. And unfortunately, it's a little mature. So there's things I have like builder patterns and stuff like that I guess maybe we can try to pull those out. But just want to make that, make it aware up front that unfortunately I'm not going to be like doing any live coding. We can try to do a little bit of live coding, but mostly what I'm going to show has already been thought out. So hopefully it won't be too confusing because it's so, I guess, mature or whatever. And I'm looking at the camera view, and let me adjust you, Jason, real quick, because you're all right there. Perfect. All right, cool. You were kind of at the bottom of your thumbnail there. All right, so let me describe the problem I had. So basically, I have this top-down camera, and I think I mentioned it earlier in the stream, and it might be a little hard to see. Let me see if I can actually go in full screen mode. So you might notice that there are these lines here, these red, green, and blue lines. So they're actually rectangles, and this is basically the top-down camera view. So I want to show you the behavior. Hey, Jason, do you know if there's a way to actually increase the thickness of these lines with the gizmos, or is that as thick as
yeah, well, about the line specifically, I'm not sure. But yeah, over here is where all of the sizes of different things are. I'm not sure specific. You mean like just the gizmo lines you draw?
I just want to make these lines thicker so they're easier to see on stream. I don't know if those are obvious, that this is a blue line and this is a green and red line. I know you can change the color, but I don't think you can actually change the thickness. Well, anyway, hopefully this will be easy to see. Actually, what I could do is just clear out this scene so that it's just like, you know, a white or sandy background.
Well, there's actually, if you look at the hierarchy view, you can actually hit the little eyeball beside hierarchies of things. Oh, which version are you in? Yeah, so if you hit the eyeball, it'll turn off that entire suite of visual stuff for rendering, and you can use that to sort of disable visually certain elements to make it easier to see stuff.
Wow, that's a big sheet. My bad. Okay, let's see if we can get the point across. All right, so check it out. Basically, I had this camera, and the challenge that I had here is a visual one. Visual because I just wanted to make sure that you know, it was working correctly, and it required a little bit of math and logic that I was struggling with personally. So basically, the whole point is I want this camera to follow the character into the next scene. So as soon as I hop into the next scene, I want to be able to be taken to that scene. Another example is if we go over here. Boom, you can see that the camera follows into the next scene. Now, it looks simple, and it really is a simple thing to explain, but for me, I just struggled to figure out logically how to make this work, because there was a lot of things to consider. As you can see,
like intersecting bounds rects and all that kind of stuff. It actually answers one of the questions earlier where someone said, give example of a system that turned out to be more complicated than you thought it would be. Well, perfect. Anybody who's worked with either character controllers or camera controllers, they're two things that are usually, it's like, oh, it's just a camera, I'll just point at the thing and whatever. It's like, no, you've got to deal with collisions and interpolation and making sure that you've got your view rects right and all this kind of, like, it starts to grow very quickly in complexity.
Yeah, and this one grew very quickly. So if you can see here in the bottom right, I have the top-down camera this is the mono behavior as it shows up in the drawer. And you can see that I have this concept of a view size, the size of the bounds, and then an offset. So again, this is mature. This is after I've solved all the problems. But basically what I came to find is that I'm going to need to be able to determine when this little sheep guy goes out of his bounds, and when he does, then I need to adjust the view. But that is based on the bounds. On top of all that, it always needs to be in the center of the view. And that's why we have this separate view size. So it's hard for me to explain because it's already done. But before I wrote tests and before I really started writing any code, all I was doing was just trying to move this little sheep around. I was doing this. I was in the rocket ship, you know, using my earlier analogy, and I was just trying to move them around and try to understand, okay, when I pass this line, is it doing what I expect? And then I'd hop over to the code and I'd try to, like, you know, I have this reposition method here, and I would try to update it and change some values here. I mean, you can see all this math. I'm looking at it now, and I swear I barely remember writing any of this, and I can't even make sense of it right now if I were to have to explain to you what this does. But let me tell you, it was difficult. So how do you solve that problem? Well, I could solve it in the slow way, which is making a change to a value, which I would do. Boom. And then I would go back to Unity, wait for it to recompile. Then I'd run it. Well,
eyeball test.
And I even cut down my feedback loop by having this thing run in edit mode, so I can move the sheep around and see it move. And I would literally is it, you know, and then it would turn out there was an issue where, because I was using whole values, that this sheep jumps on a grid, you know, it'll always be on an int like 6, 7, or 8 on the X and Y, that I thought it was working, but it actually wasn't working. It just looked like it was working. So anyway, long story short, how do I solve this? Well, I turned to unit tests, because at least I knew with unit tests, I could set up a suite of things to check and make sure that all the green check marks or all the check marks turn green, and then I would know that it would work. And that really cut down a lot of the time of development here. So this is what you're looking at here, my suite of tests. Let me pull this open here, find my sheet. Actually, I can just run it. I'm using Rider, by the way. I know this question gets asked a lot. I'm using Rider. It's an IDE or a code editor that's by this company called JetBrains. Highly recommend it if you've never used it. But it's basically Visual Studio, but with, in my opinion, better integration with Unity and a lot of other great tools like source control, and this test runner here is very nice, except it doesn't seem to be working. But I highly recommend it. Definitely check that out. It might not be working because it wants me to save. It always does that. So let that save. And basically what's happening here is it's actually running this code. We want to make sure not to run it in play mode. I'm going to run it in edit mode, and that's going to allow me to run these tests. And then we should see that they all go green. Yeah, all right. So they're all green. So that's great. I ran my tests. And now we can see what are the tests. Well, the tests make up the basic expected mechanics of this top-down camera. First, I want to make sure that the big one is I want to make sure that it sets the position to the center of the view. I always want to make sure that's no matter what the position of the player or the camera, it has to be in the center of the view. The other thing is I need to set the position based on the player position and the size of bounds. That was another thing that I determined needed to be done. Also, just kind of as a minor side, I guess, what do you call it?
Sidebar?
Yeah, I wanted to make sure that it didn't update the Z value. Basically, it was screwing me up to where when I would run it, it would change the Z value to 0, and then you wouldn't see anything in the game view. So I was like, oh shoot, well let me put in a test for that. Why not? So I did that, put that in there. And then lastly, I want to account for the offset. And again, going back to the editor, I have this offset here. If we look at the scene view, my tile map, I'm using a tile map here, which is built into Unity. It's just offset by 0.5. So I just added that in there. All right, so if we look at
as a small aside there, we just got a question from Hitoshi, and are unit tests applicable to loop-driven code? So I've said this before. It's not ideal for loop-driven code because it sort of works in steps. But here's the interesting thing. If you think about it, all code is technically steps. It's just a loop. It's just the steps running fast at a certain amount of time. So oftentimes when you're testing loop-driven code, what you're actually testing is after X number of cycles, the state has changed. And so what you can do to test that is you can check values. You can run the update call 50 times, check values. And in fact, not only does that let you test it, if you know a tick rate of 0.02 or whatever, you can actually test right down to, in a hypothetical world where I had a fixed frame rate and it's ticking at this value, if I call update gun or update the self-generating shields or whatever, you can pass in updates at 0.02 and you know it's supposed to update at X time per second. You can actually not only test that the update is happening, you can test that it's happening exactly by saying, given a frame rate of X, given 10 frames, it should look like this. Is that always practical? Not really. But I have done it in a few cases for things like gun reloads and whatever. I've had stuff where it's like, if you've got a gun that's firing in a repeater, I've written an entire gun system before, which has reloads, has barrels with bullets in it. You can reload different kinds of bullets. You can have swap out different components of the gun that would add different effects and whatever. And all of this can be tested. And at the end of the day, when it's all done, it just calls a fire function and passes in the bullet factory. And then the fire function will call on the rate of tick of whatever called it with those bullets it'll instantiate. So I could test this by saying, what if it fires X number of seconds, but then waits. It's just an integer that I tick up and check. Did it call that value? Yes. Okay, cool. So it worked. It hypothetically fired. And then I brought that entire system into Unity, and I just created something called I think it's a physics game object barrel or something. And it's effectively on fire, instantiate this prefab and apply a physics force to it and fire at this fire point. And so it just attaches to the end of the entire gun system, and I've now got physics-based bullets. And then as a test, I decided this isn't very performant. I want this to be a hit scan. So I switched it out for a recast barrel. And all of the code's identical. All I did was swap out that one bit at the end, which says instead of spawning an object and then adding force, spawn a fire array, check if it hits, and then check the object's component type and call damageable or get damage on the damageable and apply it. So the entire gun, the recoil, the bullet types, all of that stuff, it's identical. None of that changed, but I could drastically change the entire gun system from being hit scan versus projectile based with one class at the end, and that was loop driven, right? Because it's like ticking the updates for animations for all that kind of stuff. So that stuff can be tested. The way I did it is personally is I just passed in a float for delta, and the delta just represents some amount of time. In Unity, I'm just like directly passing in time delta time. In my tests, I pass in 0.02, and I just pretend that's the frame rate, and I run my tests as if X number of frames fired. But yeah, so it's doable. It's just probably too much work for something that isn't like a large system that you're building that has to be maintained.
Yeah. In this case, this reposition does get called every loop, every update. The way I handled it was I just literally pulled it into a method called reposition, and then I just call it an update and start. So just, some simple solution. Hopefully, what I could have done is I could have made it its own class or something like that. But in this case, I just felt, you know what, I'm just going to expose it as a method, and Bob's your uncle. That's it. All right. Oh, another question is from Nick. Kathy, how many times do your tests fail in dev? Lots of times I see that they all pass in your videos. Well, yeah, definitely in my videos, I generally get to the end point really fast, so you're not seeing that process, but they definitely fail a lot as I develop. Well, it really depends on what I'm developing. In this case, what happened? Bad audio? I turned into a robot?
Yeah.
Oh no. Can you hear me? Like that?
Yes, I can hear you, but not well.
You talk. I'm gonna fix this.
So yeah,
Charles
goes and Charles goes and fights the doctor. The rest of us can stay here and try to figure out the code. But yeah, so basically, as Charles was pointing out, he basically has a system which conceptually feels like a Unity system. You're talking about something that is fundamentally Unity. It's the camera. And your instinct would be, well, how do you test that outside of Unity? And the thing is, you're not actually testing a camera. You're testing, does a rectangle intersect with another rectangle? Is it reaching certain values? Does a particular X value go outside a particular range? If you really look at the problem you're solving, it's actually got nothing to do with Unity at all. It just happens to be visually. Oh, great, now I'm muted. I'm back? Okay, cool. So, Charles, can't hear you, Charles. To be fair, I think we got pretty far. Like, this is not bad. We got a good lot in before the audio started messing up.
Can you hear me now?
Yeah, there you are.
Hey-o. Look, I'm a master at fixing problems, man. Live. How do you like that? Am I still a robot?
No, all good.
I can't wait to play back my Mr. Roboto voice. That's going to be fantastic. Yeah. All right, let me switch back to the code. Gosh. Woo! We did it. Where were we?
You were about to demonstrate the test you wrote for the centering of the direct.
All right. Oh, well, the question real quickly to answer is it depends on what I'm developing, where my tests would either fail like a lot or not at all. If I'm just wanting to write unit tests to make sure that something gosh, inaudible code. If I was
going to say that is a fantastic meme. I was looking inaudible code. Beautiful.
If I'm just testing something that I've already developed and I know how it works and I understand it, typically I should be able to write the test and it'll just run and pass. and then I have that sort of implicit documentation for later when I forget what a function does or how to use a function. I can look at the unit tests, or if it's going to be something under heavy development in the future, I know that I won't have regressions later on.
And this is one thing we haven't actually talked about regressions. I think we should probably pause on that for a second.
Okay, yeah.
Because another common thing I hear is people say, look, it's just a health bar. It's like an if statement. If health greater than whatever, clamp max health. If health less than 0, clamp to 0. Why am I writing tests for something that's so obvious? It's apparent on the face of it. It makes perfect sense. Well, because code changes. Like, it's 100% going to change.
Yeah.
How many times have you decided later that you're going to add some concept of a maybe the health will regenerate. Maybe health now becomes health and shields. Maybe you have health packs, which apply health over a certain length of time, versus the healing station, which applies it instantly, versus some magic spell or healing aura or whatever. And as time goes by, you're going to add little things into your code. You're going to add like, if the health is coming from an ally, it gets X amount of speed, versus, this is actually health coming from a global health source, and therefore it changes at a different rate. You don't know yet what you're going to do. Now, I'm not saying you should architect in advance for these things, but if you test that the features make sense, test that health can't go below 0, and test that health can't go above max, then all other things being equal, those extra 10 minutes you spent writing just a few verifications means down the line, when you start adding messy new features in the middle of that code, you can check that you didn't break existing features. And that's what we mean when we say regressions, because you'll have done this. If you're honest with yourself, you will have done this. You'll have written some code. You'll go over a whole unrelated system. You'll add something. You'll go, actually, I need this thing. So you just hack in a little line of code. All of a sudden, hang on a second. Why is my movement stopping working? It was working earlier. It's not working now. What the hell happened? And that is because it's a regression. You introduced a bug when working on new features. And it may sound silly to say over-test these kind of micro features like health bars and basic stuff, but that's what's going to save you time. Because when time comes by later and you've got some really weird esoteric bug, you're like 2 days out from publishing and you're just going, oh my God, 2 days from release, all of a sudden none of the UI is rendering, or none of the characters aren't moving anymore, or there's this horrible bug where you're colliding through only half of the boxes, or damage isn't being calculated and you're freaking out. If you can go back and just check that, okay, at least it's not the health system. Next. Okay, it's not the collision system. Next. Okay, here's the bug. I didn't have this thing hooked up to this thing. If you can just like remove the risk of it being those things, you're going to save hours looking in the wrong direction. And that's not an exaggeration. Like, it's one of those things where 10 minutes of just writing some basic, if it's this, do this, if it's this, do this, and then just don't look at it again. You now have a test to verify that it does the basics it's meant to do. And yeah, like, I can't stress how many times that saved me hours of hunting. And, again, you don't have to do it if it doesn't suit you, but like, all I can say is I would swear by it,
Well, another example, talking about, like maybe your days from publishing. Well, what if it's like the boss on level 6 is doing some weird thing now because he happens to have a health bar as well, and the bug doesn't manifest on the player because the player doesn't have anything fancy going on. But maybe this level 6 boss does some sort of regeneration logic where it regens when it's standing in a certain circle, and you want to kite it away from that circle. Well, you're not going to know about that. And that could get shipped, and you might never know about it. It might be something that gets exploited, and something that just screws up the release of your game. So
and to avoid strawman, we're not saying that if you do unit tests, you will be bulletproof and your code will never break. What we're saying is it will cover a lot of obvious sounding test cases. You will be able to cut out the time it takes to hunt for bugs. You will have a little bit more certainty with your code, and there's this concept of removing fear. Which is, if you've got a system that works and you want to add a new feature, again, if you're being honest with yourself, you've done this, you've got some piece of code that does something cool, some shooting system, some teleporting system, you've built something cool that you like. And you're like, oh, it'd be nice if I added this feature and it could do this thing. And then you stop, and the back of your mind says, no, don't add it. I said, why? Well, because it works right now. And if I go in and start adding new code, it might break. And you're like, yeah, that's a good point. Maybe I'll just work on this other thing instead. And so you stop being creative. You stop adding the new things you want to add because you're afraid that you'll have to untangle the mess of stuff you've got. Now, I'm not saying that this will solve every case, but if you can run a bunch of tests and say, yeah, it still teleports, still collides with the ground, still does raycast, still does whatever, you'll feel a lot safer going in and going, you know what, maybe I'll change a few things, check it still works, change a few things, check that it still works. And you will have psychological comfort that your code is good. That's one of those things that you can't, no matter how many times we explain this, you can't describe the value of being able to say, you know what, maybe I will rewrite my code. Maybe I will add these crazy new features because I'm confident that at least this portion of it will still work afterwards. And if I mess up, I can just rewind back the commit that I made because I can see it the minute it happens. And not only is this valuable, you can have runtime tests or kind of continuous test times. So we're not just saying like verify the tests work. Literally, I'll have a second monitor with the tests running.
Yeah.
So as I'm typing, if I make a mistake, this screen flashes at me. It's like, oh, I pressed this button, I changed the number for the max health, and my tests broke. Like, I don't have to guess, will this hypothetically potentially cause a bug when I build it and run it and add it to Unity and press play? I can see I press the value that returns a false instead of true. It will break. It did break. I can see it. And that's sort of crazy. Like, it's a really, really powerful tool to have.
Yeah. And, a lot of what you're saying might sound idealistic, but it really, in practice, we've both experienced that, and it's such a nice feeling to have that. And then another thing someone mentioned in the chat is, and I even said it too, like, I'm looking at this top-down logic. I don't know I don't
remember how it works. Yeah,
I can't make heads or tails of this. I don't know. Yeah. All I know is that at some point, Past Charlie wrote these tests. They work. I trust Past Charles sometimes. He kind of can be a jerk to future Charles, but in this case, I trust that what I wrote worked, and now I don't have to think about it anymore. Like it's gone from my mental cache of things to think about, and we're good to go. Another question was, do I use N substitute? And I think we both do. Another thing we also use is Fluent Assertions.
Fluent Assertions. Yeah. There's a few others. There's another one. You can use auto fixture as well if you want to generate data. If you don't want to write your own builders, you can use auto fixture. I don't like it though. That's not true. I think it's good, and I like what it does.
Yeah.
I just find it's kind of like extenject or whatever. It's usually unnecessary for the scale of things I'm doing. But it's, yeah.
Another question was if we could do something live. And I think that what we were looking at last week.
If you haven't seen the last stream, like we demonstrate a very big, well, I'd say very big, but it's a project which goes from end to end of here are tests, here is code, here's how to automatically move that code into Unity, here's the outcome in Unity, and here's how to attach it in Unity. So the vending machine example in that last stream, we don't do it all step by step, but we show the process of kind of what the end result of everything we're talking about looks like. Yeah. So, yeah.
But I think at one point we can do like a stream where we do unit testing live and walk through an example.
Yeah, maybe like an inventory or a health system or something that we can like really quickly put together, demonstrate, move into Unity, draw visuals for, do something like that.
Yeah, I think that'd be good. Something for my sheep game, so I have some motivation to work on it a little bit more.
Well, maybe we do the whole water thing. That'd be hilarious. We brought it up 2 or 3 times.
That actually would be kind of cool. Yeah.
Maybe the sheep's wool contains water, and you could have some sort of like something that slows it down, and it goes stuck to the river or something.
It could be a mechanic, or like part of the game's like you got to fill a bucket with water, so the sheep runs to the lake and jumps in and comes out and squeezes himself out. That could be kind of funny. Cool. So. Let me just see where we are with the time. Where are we at? We're at an hour and 22 minutes. All right. So I can just really rapidly shoot through these, even though I don't really think it'd be that valuable. Let's just look at this first case. And again, it's pretty advanced already in the sense that I have created a builder for it. So a lot of this is going to be like, it looks a little magical. Like, what am I doing? A game object with position? What is that? I coded that. That is completely custom code. It's based on the builder pattern, which I think I have a video on. But essentially, if you look at what the test is, and again, looking back at the theme that I don't know what the hell this code does. I couldn't tell you if I gun to my head. All I know is like if I have a game object with this position 220, okay, I've got a top-down camera. It's at position 2020, so it's off in no man's land. It has a target. Okay, it's this target, which I know is at position 22. Cool. It has a view size of 4.4 and a view size with size of bounds 2.2 and an offset of 0.0. I kind of in my mind's eye can sort of that remember I created that gizmo. I can kind of use that same concept in my mind and okay, well, I know the view is 4, the size is down here. Okay, what do we got? It's going to call reposition. All right. Well, I know that this top-down camera was at 2020 when I started this test. Well, when I called reposition, now I'm looking at the camera transform, top-down camera's position, and now it's at 2.2. Oh, okay. So what does it do? It sticks it in the center of the view. How do I know that? Because that's what the name of the test is. I knew that based off of the starting state. It was all the way over in no man's land. And now that I know if I call it, it's going to stick it in the center of the view, presumably. And hopefully at the time that I've added some, maybe there's some other feature that I added in here, some line of code where maybe there's like something where it's like, oh, it has to be locked, right? So it gets some value for locked, and I say if not locked, but maybe I flip the bool by accident and I stick if locked return, or if I do if not locked return, and I update my tests and all that. Well, I'll know that if these tests failed for whatever reason, I know I can come back here, and if I don't understand what this logic does, and if I'm confused about it, at least I can step through this code and hopefully get some sort of idea, at least at a high level, what it's trying to do. As opposed to if there was no test, if this suddenly broke one day and I had to come into this method and say, and this is a bad example, obviously, this is very clear, that I flipped the bool, I would think, but let's just pretend I added some different logic.
And again, like the other thing too is like, keep in mind when we do a tutorial or an example, we are purposefully showing you something that hopefully is clear and isolated and covers a point.
Yeah.
But when you have a game, as we all know this too, when your game is big enough, you don't have 2 or 3 scripts. You've got thousands of scripts, and they're all doing small things. And the 5-line thing at the start of your project where you managed your camera movement that you haven't looked at in 3 months, you may not remember it. You may not remember how it works. And if you decide to add a new feature to the camera now, you've got a bit of work ahead of you going back and trying to remember how you wrote it. What was the name of the script again? How did it work? What's the method I'm supposed to call? Do I need to pass in certain values? How did I choose to design this? And so another fun side effect of testing like this is you've got documentation. Mm-hmm. Like as if you go back to the test there, Charles, as you say, it's like if you've never used this system before, you have no idea what it is, and you want to figure out how it works, it's pretty hard to get cleaner examples. There's no abstract sentence, no documentation that you have to kind of read and try to translate to code. It is pretty clear that when you have a game object at a certain position, when you've got a camera at a certain position, with that game object as the target, with a particular view size, with a particular view bounds, with a particular offset, and you reposition it, this happens. Like, you can't really get much clearer. And so having this as a reminder is kind of cool in and of itself, separate from all the other benefits we talked about. Like, I can't be the only person who's opened a script I wrote and went, who wrote? Oh, I did. How does this? And then you're trying to remember how it works. And you're like, why did I do it that way? And what was that called again? And you're like, being able to go back and verify not only that it works, but to see what tests you wrote that imply the usage of how it's supposed to work is particularly cool.
Yeah. And for me, as I was writing this, I really, again, I didn't start with the unit test. I figured I could just get it going, and I thought I had it working, but I kept finding that even though it looked like it was working in the editor, even though I was eyeballing it, whenever my player got to this position, it was not changing the view. And I was like, okay, I can no longer do this visually. I need to make the test. And I'm glad I did, because honestly, I wouldn't be able to explain what it does. So yeah, that implicit documentation is something that I think that gets lost as well. I don't think people talk about that enough. You do get some documentation. And it's funny that I actually, I look, if I'm going to pick up a framework like ZenCheck or something, I'll go and look and see if there's any unit tests, because it'll help me understand, how certain classes are being called. And like, it might be very clear, in the documentation, oh yeah, you want to use this class and call this method. But I might think, well, what else can this class do? Who knows better than the developer who wrote tests for his own code or her own code? A lot of times documentation is lacking, and there are things that are implemented that never get documented. So, I'm not saying that it's a hard and fast rule, like always look at the unit tests, but I've found, cases, anecdotally, where I've looked at the unit tests and thought, oh wow, I didn't know it could do that. I didn't see that in the documentation. And that was kind of
so there's a really clever comment I read. I think it was a Kent Beck book. I can't remember, but it was one of those things that was just thought, this is really smart. It was basically the idea that when you're talking about refactoring, so if you've got an existing code base, there's the classic cliche that you join a company, they've got this giant code base that's 2 years old, and you have to work with this thing. Now, again, probably not the same in game development very often, but like if you've ever been brought in to work on a legacy project, there's that instant sense of, oh my God, what has happened here? When did this go so wrong? And when can we restart it from scratch and build it again? Now, without getting into the whole concept of the philosophy of, tiger teams and refactoring and all that stuff, I will say one thing. I used to be the same kind of thing where it's like, I'm coming in with fresh ideas and clean code mentality, and we should like scrap it to the ground and start again. But a great bit of advice I heard once was, and again, I think it was a Kent Bett book, was you would look at some weird line of code, some sort of shiv or some weird thing where it's like, actually, if this comes in and this user's department is blank, then do this thing. Or if this thing happens and they've got this ID with their name, then route them to this particular department or whatever it is. Or in a game case, it might be if this enemy is of type orc, change their weapon damage multiplier by 2. Now, what you just noticed looks like this weird, hacky, confusing piece of code. But the thing is, that's a patch. That is a business rule or requirement or game mechanic, whatever you want to call it, that came in later, that wasn't thought of at first, that isn't written down, isn't part of the documentation. It grew out of understanding of the system and has been added to the code. And so if you try to write a clean from scratch project, you're going to have a lot of holes in it that you don't realize are there, that have only been found by being out in the wild and working. When people have literally used a project, hit these things, says, hang on a second, this should be this in this case. And so people are adding these patches as they go. And so if you start from scratch, unless you're paying very close attention to every single one of these patches that have been added, what you're going to find is you're going to write to the spec of the original system, not to the end system that you ended up with. Yeah. And this gets to a wider philosophy of the idea of refactoring, where if you've got a system that exists, what is the best way to rewrite it? And this is a side tangent, but it will highlight again why tests are so valuable. If I've got a system that's written badly, or it's messy, or it's confusing, or it's hard to work with, the way I would go about fixing that system is I would write tests for it first. Because if I write a test that says, when I pass in a number here, this happens and it spits out this number, that's the intended behavior. Now, the code is a mess and I don't know why it does that, but I've been told by the bosses that if this number goes in, this number comes out. That's what it's supposed to do. It's supposed to print a report. It's supposed to send an email. It's supposed to do something. So I would say, cool, it needs to do this. As long as it still does this, it's still a working system. So you write a test, verify it works, and then you start gutting it and start changing stuff and whatever. And you keep an eye on those green dots. And the minute one of those dots goes red, you're like, oh, I broke something.
Yeah.
Undo that and try again. Oh, still green, and then you can go. So this is that safety again, that sort of removing of fear. And so a lot of this stuff, like, you can't rely on some external documentation. The code is your documentation because it is literally the spec. And I've said this before, so I won't go down a whole rabbit hole again. But like, code is for you. It is not for the computer. The computer doesn't speak the language you're writing. People do. So the spec you're writing is designed to be the documentation. It's actually technically the code, but it's also the documentation. So what you're writing should make sense. You shouldn't have to have instructions that guide you on how the code works. The code should make sense. And if the code doesn't make sense, the tests that verify that it works should make sense to explain that the code makes sense. Yeah. So yeah, it's a very powerful concept to start thinking in terms of code that tests the code and also tells you how the code's supposed to work.
Yeah. Well, hopefully we adequately explained it, and I'm sure there will be some comments that we may have missed. If anyone's watching this right now and you're like, I don't agree, or I do agree, whatever, please leave a comment in the VOD. We will respond to that. We do our best to respond to all comments, and I think maybe next week or the week after we could. Maybe Jason and I can work on trying to do a live example of something simple like an inventory system.
I admit that was the intention, but due to technical difficulties, and also I don't know if it's very noticeable, but I'm currently on a new computer and my office is getting a bit of a renovation at the moment. So things are a bit all over the place for me. So I haven't really had time to put together an example project, but hopefully next time we'll put together something that steps through a little bit clearer. Yeah. But I do want to put one caveat on that is some people are saying, can you do a big end-to-end example? And we're never really going to do that because it's kind of like trying to explain architecture to somebody by saying, let's build a skyscraper. You can't do that. You can't explain a topic by doing a full, large practical example. You need to isolate ideas, and then the goal of the person learning is to extrapolate those ideas to larger systems. If we don't bridge the gap well enough, we'll do our best to try to explain stuff. But there's like it's very, very difficult to take 12 years of doing this and distill it down into one or two things. And so you kind of need to just pick a window and explain it, and then pick the next window and explain it. And over experience of playing with these things, you'll get better at merging them together. So we'll use small examples, we'll use health systems and that kind of thing. But the idea is, if you understand the principles of how we program a health system or a inventory system using these ideas, if you're building an A-star pathfinding system, the concepts are the same. You're just going to have to extrapolate the differences between the two.
Yeah. Cool. Alrighty, well, thank you all for joining us today. It was a great stream. Had a little bumpy start, but we made it through. I hope you all did my robot voice. And I guess have a good Sunday. I'm not sure if we're gonna have a video next week or a live stream, but stay tuned to this Discord channel. That's where you'll know, and Twitter as well, even though I'm terrible at Twitter. So Discord's your best bet. And if you're subscribed to the channel and you have your notifications on, you'll also get a notification as well. So yeah, I don't want to commit to anything just yet. As I've mentioned on a couple of different streams, in the process of moving. In fact, tomorrow my wife and I are closing on the house, so been really, really busy with all that. So I apologize that there hasn't been a dedicated video, but these streams are fun. I hope everyone enjoys them, and we'll try to do one again next week.
So, and like we said, we're sort of picking topics out that we think are lacking representation.
Yeah.
And to be honest, we are kind of just attacking it from angles based on comments and based on what we're trying to kind of get across. But the more advice you can give us in terms of where issues aren't as clear, the more we can focus on those. So if you have any comments in particular, feel free to write them on the video. Join the Discord, comment there. Upvotes would be nice too if you have those handy.
Smash that like button.
We'll basically start tailoring content in that direction.
Yeah.
And we're well aware people want a lot more practical examples, and that's why, if you saw the last stream, like we do have, we're aiming more towards having code to show you. But again, the fact of the matter is, like, it's a huge time and effort intensive process to build an entire project, to try to demonstrate it. And then, just like Charles was saying here, we're just trying to talk about tests here, but there's already test doubles and builder patterns and fluent assertions and dealing with command query separation. And it's like a whole load of topics that like are baked into the assumptions of just writing 3 lines of code. And so the idea that we could take a project that would take a month or 2 to make and try to explain everything is pretty unlikely. So instead, if we can pick small areas that are kind of more issues, we can focus on those and we can try to cover them as best way as possible.
Yeah, definitely. All right, guys. Catch you later.
Good night.